1. An atlas can be used by putting atlas path name, and then the name without extension, where an image file name is required. 2. This is the first half of program to create atlas, and the most important. The glob module is used, which calls other modules. In the glob.glob, we write the file names it should search for. These correspond to 26 letters of size 64 by 64 in set 1. Besides the letters, the space character is inserted. The way to create space is to open the included vector graphic ending space or similar program and deleting the contents and exporting as 64 by 64 PNG. Then the letters atlas is created using the create function. 3. The last two files are the files created by createAtlas. The input images are not shown, since they are not needed anymore. 4. These are the imports. A module split lines is needed to split a large string into many lines. An implementation is included on Blogspot. The string standard library is included, so we can use the constants like the 26 letters rather than typing each. The other imports are similar to the previous example. 5. This is the string to output. Note, this is only one string, even though it is on many lines. Next, the constants I and j are defined. The number of maximum characters in a line is 2i. The maximum number of lines is 2j. It is possible the string will not fit into 2j lines, and thus we will only see a partial string in the output. The split lines module is used to create lines, which is a list of length 2j. 6. Next, we form the 27 image strings. These correspond to the 26 letters and a space character. In the template, we start with atlas, :// then the relative path, then the name, without an extension. The coordinates, ORIGX and ORIGY, refer to the lower left of the region, where text will be displayed. 7. The letter class has a string property, which will be used to hold the image string. Next, in the root, there is only one function, writeString. It uses an integer variable to iterate over the 2j lines. Next, for each line, we iterate over all the individual characters in the particular line. 8. For each character in a line, we create a letter instance. Then its string property is set to a letter or space. Notice, if we have a comma or period, it will be treated as a space. Then, the x and y positions of the letter are set as some offset from the ORIGX and ORIGY coordinates. Finally, the letter instance is added to root widget. 9. In the app, we schedule the writeString function to take place in half a second. 10. In the Kivy file, each letter source is set to image string property. Also, the size is set to 32 by 32. Since the image is 64 by 64, it is scaled by 50%. 11. Finally, we set a gray background color. 12. In this result, we can see the string has been written over many lines. Also, it can be seen that the commas and periods are missing and replaced with spaces. If we had the images of the two symbols, we can easily write more conditions. 13. You can find additional information including the source code at pythonmobile.blogspot.com.